everybody, it is Zach the Welder, and I have a cool repair video for y'all this week. So, if you've never seen one of these, this is part of a sanitary valve. So what you would have is there's a plunger that will rest inside this guy, move up and down. Your product will flow in here and it will either come out the bottom or it will go through the upper part of the valve here that I do not have. But as you can see, this looks a little off. So what happened here is just in the process in this plant, this valve body gets cleaned out of place. So typically in your process piping like that, there's CIP, which is clean in place, and COP, which is clean out of place. So this valve gets COP'd, and in between removing it from its location to a COP tank, which is basically just a jacuzzi that's heated with steam that has jets that circulates the cleaning fluid through stuff like this, somebody dropped it. And this valve body is like $1,000. And I can repair it real easily with a ferrule that's like $5 off McMaster-Carr. What we're gonna do here is we're gonna chunk this in my little Monarch lathe. We're gonna go ahead and turn this bottom ferrule off here. We're gonna go out to the other shop. We're gonna drop that part, and we're gonna go ahead and weld that ferrule on right here. And I'm gonna take you guys and show you this in real time so you get an idea of just how quick you can do a repair like. So before we put this in the lathe here, I wanna talk a little bit more here. So these ferrules, the ones that I get at least, are 1.1 inch long. So what we're gonna do is we're gonna put this in the lathe and we're gonna part off 1.8 inch from this face here over so we get a nice true edge to where this ferrule will remain parallel to this mating surface here. Now in the application of this one, if I'm off a little bit, it's not gonna be the end of the world. If this was a super critical hard pipe to hard pipe fit up, probably what I would do would be account for the weld shrinking here. So when you do a sanitary weld like this, typically I will allow 2 32nds of an inch to maybe 3 32nds of an inch, depending on the size tubing, for shrinkage. So when you butt them up against each other like that and then you weld it, the weld will actually cause it to shrink a little bit. So on a single one like this, it's not a big deal, but if you're, say, doing like a whole bunch of valves together here and you have a hard pipe that has to hit everything there, you have to include your weld shrinkage when you make your cuts to where your piece will be longer to where it will not fit, but then once you weld it, it will shrink into place. So here we're just gonna go ahead and put this in the lathe and part off 1.8 inch, so it's not super critical for this particular one because I know where it goes. All right, so high-speed steel does not play particularly well with 304 stainless steel, so you got to run it really slow and make sure you use lots of coolant or lube. So just a FYI there, if you run it fast, you're too high on your surface feet per minute on your material going over it, you'll just wreck this. So yeah. Anyway, we'll go ahead. I've got the DRO set up behind me here, so I'm gonna go ahead and measure off of this face here, and then we can just measure over 1.8 inches. And so if you have a lathe on it like this with a DRO, it makes it really easy because I can just go ahead and crank this over. And there's my flange on this is pretty messed up, but I'll just look for a good spot here and crank this in. And right there, we're touching, so that can be my 0 point. So, wait. And I gotta remember, because I don't use this DRO a whole lot, right there, X, as you can see from the cobwebs. Okay, so there we set this face as X, so I can go ahead and go over, and then now, as long as I crank that to where this is 1.125, we should be 1.8 inches from that face to that face, and just to eyeball it, I'll go ahead. Now this is a 2-speed, so we need to go ahead and shift it into low gear, and we'll see how fast we're going there. Okay, that's about as fast as I wanted it to go. So now we'll go ahead and get some lube here. I really like using this Tap Magic Extra Thick for stainless like this. Not sponsored by them or anything, it just seems to work really well, so that's what I use. So we'll go ahead and grab that. Actually, I forgot to grab an acid brush while I was over there. And yeah, we'll go ahead and get this guy rolling here because I'd like to get this done and finish up for the day. But like I said, I wanted to do this in real time so you get an idea of how long it takes. So I'm gonna put you guys down here so you can kind of see what's going on here. So we're gonna go ahead and turn this on. I'm gonna inch this guy in a little bit, make sure that's tight, get a little bit of looby lube lube here. Right there. That is the one downfall to this. Is not a geared head lathe. This is a belt driven, so you have to watch when you're parting that you don't have a whole lot of torque. So, and that kind of twisted that on there, so I need to go ahead and recheck that. Right there, okay. Now this is a little difficult because this thing has been dropped, and so that is not exactly centered there. So you got to kind of go slow until you get a good cutting path. So that was kind of on me there. But I am not going to edit any of this out because I told you I wanted to do this in real time so you get an idea of just kind of what a repair like this takes. But I do think I will speed this up a little bit here. There we go. Now we're actually starting to get a decent kind of consistent cut around there. There we go. Now I'm actually getting chips rather than just that. Oop. I got to talking and not paying attention to it. So let me go ahead and do this and actually pay attention to it rather than talk. Okay. Wait, did I chip that where I need to sharpen that? Oh. Before I get going here, I actually need to sharpen this tool bit. So, okay, so I should have checked to see if that was sharp in the first place. I don't think it was. So we'll go ahead and take two here. There we go. We're actually getting a nice, decent chip. That was my fault. I should have sharpened that guy before we started. So you gotta be careful because you have that piece going round and round there. We're making nice chips this go round. Probably turn that down just a little bit. And again, I am not an everyday machinist. I'm sure there's people out there laughing at this, but hey, I am very much a YouTube machinist. When you get down to the end on a tube like that, it wants to bite in. So, yeah. Again. Oops. When they make these, they weld them up and then they polish them. So I've got a spot there where the wall is a lot thinner than the rest. And so as soon as that tool bit goes in there, it wants to grab. So I got to be real careful here as I get through the rest of that and go really slow. But we'll come in after this is off there with a piece of carbide and clean that edge up. Just kind of have to go slow. There we go. All right, so that guy's parted off there. So we'll go ahead, we'll throw a regular cutter in there and just come along there and clean that edge up. I don't need to get too crazy, I just kind of want to true it up. There we go. So now this guy is gone. We can go ahead and dump that guy in the scrap bin. So now we're going to be ready to weld this guy on here as soon as we clean that up. We'll go out to the other shop and do the rest of this. Well, now we got to walk out to the other shop because I don't have any stuff for purging in the machine shop anymore. But check that out. I got my parking lot done where I can actually turn a semi around out here. That's really exciting. I had some metal delivered yesterday and yeah, the Alro truck just pulled in, like full-size semi just pulled in and turned around there. I unloaded them like a real business. There was no driving out to the end of the road with the skid steer to pick stuff up. It was really cool. So now that we're over here, we'll get set up and weld this guy out. All right, so I am just using a paper towel to clean off that Tap Magic. I guess you probably should use a acetone to really clean it, but I'm gonna polish the hell out of it anyway, so I'm not too worried about it. So, all right, so we gotta go ahead and set up my positioner here for purging. So this is a Rotostar 3, I think. This is a fairly high-end one that I actually got off eBay really cheap. So if you're looking for a positioner, if you watch eBay and you're patient, I picked up one of these dirt cheap a few years ago, and then I just upgraded to, this is the next size up than I used to have. But these are really, really cool if you do work like this, especially the Rotostars here, because they have a hollow chuck, or a hollow spindle, excuse me. So what I can do is I can just go ahead and run my argon purge line This is probably easier if I do it from the bottom of the table rather than up. But basically I can just do one of these numbers where I can run my argon through this guy here where it spins, and then I have a plate like this that just sits on top here that has argon coming out of it, and this will just hang out and spin all day long, and it works really, really well for parts like this. So I just have a hose coming off my bottle here, and then I use these 1/8 or 1/4 inch PTC fittings on everything, so I can just real quick and easily change from one thing to another. So now I just have an argon bottle over there on the other side of the shop that hooks up to this guy that will attach to that. And so now you clamp this guy down. I have argon coming up through the bottom of this, through here, and we can just go ahead and set this guy on top of there like this. And we'll put our ferrule on there and just put a piece of copper on top here to block the argon, and then an outflow cap over here, which I'll grab in a second. And yeah, this just makes it real easy if you do work like this a lot. Okay, so this is the purgeplugs.com set. Actually, I think specifically this is a rebranded one that Orbitalum sells, but I got this one off eBay for like 50 bucks. So yeah, we're gonna go ahead and use it here. These purge plugs are really awesome if you do sanitary work. It's just a little cookie like that that gets pressed in there. And then this big one on top here, I'm not sure if I can fit a 4-inch. Oh, actually, yeah, a 4-inch will fit just fine in there. So we'll go ahead and we will put that 4-inch one in the top there. I wasn't sure if that was gonna be too big. But these come in two different styles here. They come in a, outflow one, and then they come in a solid cookie. So for these particular ones with that plug in it, as long as you don't have too many joints there, I like about 15 to 20 CFH. So we'll go ahead and we will just go ahead and put a solid cookie in the side here. Since argon is heavier than water, or excuse me, argon is heavier than air, you kind of need to think it's gonna fill up the space like water. So that's gonna be good right there. We've got our outflow in the top, and we've got our just plug in the side there. So we'll go ahead and tack this guy on here. We're using the Miller Dynasty 300 just because it was already set up, and all I had to do is flick the on switch, and we're set at a blistering 47 amps. So really, you don't need a huge machine for this. All right, so I'm gonna go ahead and turn my gas on for tacking this up here, just because this is a valve and this is a really high dollar part. Generally, on normal sanitary tubing, I don't mess with that. But just, I try to make this look a little better. So we'll go ahead and light up on, I've just got a block of copper down there I like to light up on before I light up on a part like this. Again, I like these lightweight gloves because I can feel my high-low on this, make sure we're good there. So I'm gonna go ahead, I got gas flow out, usually just check your wrist. If you feel a little bit of air flowing or gas flowing like that, you're good. We'll go ahead, get a tack on this guy here. Now I did go ahead and just for tacking, I set my Dynasty at 60 amps. I'm gonna weld this out at probably 47. But I just wanted to go ahead and have a little bit more oomph for tacking here, just to make it go a little easier. And also because I do not know with this if this valve body is a little thicker than 065 wall. So when I was parting it off of there on the lathe, you could tell some parts were thicker than others. That's just from when they make these, they polish the crap out of them. So I don't know, we'll see see whether we need more heat or less heat here, but I just want to go ahead and get tacks on this guy. And I'm just going to do a bunch because we're purging the inside of it here, so I really don't care. That looks pretty good. Now I'm gonna go ahead and wire wheel the outside of this with a stainless wire wheel, just because I got some schmutz here. This has been in a facility and had some not really appetizing stuff flowing through it for most of its life. And anytime you get that with stainless like that, it will cook out and it will be gross. So I just want to clean it and make it as nice as possible here. So I'm going to wire wheel this guy real quick. So this is just like a Sioux air drill, 4,000 RPM one. And I just put a stainless wire wheel in it. And I know I probably should be wearing a face shield for this, but yeah. So I just want to knock off any crud there before we go ahead and weld this out. Generally, I like to wire wheel my tacks. I just have like a little Milwaukee cordless die grinder that I will hit with a little wire wheel in it. Just anytime I have a tack like that to make sure it is super clean before we weld it out. I've got good gas flow going there. So this setup here is a little goofy to use. I just got it. I have 1 foot pedal that controls my rotation and 1 foot pedal for the TIG torch, because really, I mean, I don't necessarily need to use lift arc for this. So we're gonna try this out here and see how this does. I'm still kind of getting used to this foot pedal arrangement because I just got this larger positioner. But, oh, I guess I should say I'm using a Jazzy 10 I'm using a Jazzy 10 cup there. So we'll go ahead and try welding this guy. So I'm lighting up. I've got a puddle established. And then right there, I am doing the rotation with my foot. And I still have the welder set at 65 amps, I think, and I am maybe 2/3 pedal, something like that. So I'm still probably around that 50, 45, 50 amps, somewhere in there. I'm just kind of going around this guy. You can use pulse and much higher amperage and go faster, but that kind of takes a little bit of work to dial in versus just low and slow like this. It's pretty much a guarantee to get a good penetration through the pipe there. So if you are also new to this type of autogenous welding, you do not use any filler. You're really just fusing it. And yeah, so basically it's just kind of a slow process, because you just have to wait for it to heat all the way through that wall to the inside. And we've got argon on the back side that not only maintains the shielding from the atmosphere, but it also provides the kind of like backrest there for the puddle, because if you don't have enough gas inside the tube, the weld will kind of shrink back and be convex. And the inverse of that is if you have too much gas in there, it will push the weld out and can blow the weld all the way out. But what you want is just a nice, even, flat weld. So with these purge plugs, like I said, 15 to 20 CFH seems to be about right. If you don't have a flow meter, just kind of where you feel the gas outflowing on your wrist there is about right. So now that I'm kind of coming around here, I'm going to taper off, and we'll let that cool for a second and take a look. And I got a couple spots in there I'll probably hit again, just because I can tell the body of this is not a standard thickness. So normally this would be 065 wall. I need to give it a little more juice, but I know 47 amps with a standard ferrule like that on tubing is about what you need, but this is not exactly standard. So gonna have to give it a little more oomph for round 2. I got good penetration here, except for just in a few spots where I'm guessing the wall was thicker just because it is a valve body. And I got good outflow there. So we'll go ahead and get set up here and go for round 2. So the biggest thing with this is just kind of finding a place to get comfortable and kind of hold your torch. So I'm gonna light up. I'm keeping that puddle in front of my torch like that. Ooh, that was a little hot right there. So I started off kind of full pedal just because I want to make sure I burn through. Oh, but that was a bit much, so now I kind of backed off. About that 50 amp mark, 55, kind of if you're hand welding, it just kind of, everybody goes a little bit different speed, but you know, the slowest I've ever gone on tubing is 36 amps if I'm walking the cup and it's kind of first thing in the morning and I'm really jittery and not moving super fast. To the fastest I've ever seen anybody do is about 60 amps. And that was somebody that had been doing this for nearly as long as I have been alive. That one guy had been doing this for 35 years and was really good, but he was pretty fast. Like, so he started off using actually helium for your weld, and they ran helium for your torch up until actually pretty recently, when just helium got to the point where it was so ludicrously expensive it wasn't really worth the extra there. But I do actually have a bottle of helium. I would like to try that and see how that works out on this. But with helium, I believe your heat transfer rate is about 1.7 times. So if you're welding aluminum and you only have a 250 amp machine, it works really well to blend in just a little bit of helium in your argon line to give you that little bit of extra boost. So I believe we are around here, so I'm going to taper off and hold that for a second and see how we did. All right, yeah, let that cool for a second here, and beautiful. There we got perfect penetration all the way around. And there's a little bit of coloring in there just from where I pulled it off, but this is welded. We'll go ahead and let it cool for a second, and I'll show you how I polish stainless steel like this. All right, so this is cooled, so we're gonna go ahead and just buff that weld out where you can't tell that there's a weld there. The inside, we're gonna do the exact same thing with. Inside on this is really all we care about. So I'm just gonna go ahead and put this in my rollout wheel, and to make it a little easier to buff the inside of it, and I'm gonna show you kind of what I use for polishing stainless. So the first thing here is I really like these gray roll-lock wheels. I really like these. You can put them in one of the M12 Milwaukee die grinders. You can get a really nice high polish on stainless steel with these. They don't do a real good job of putting some kind of grain back in the stainless. So I really like these red Scotch-Brite wheels. You can run them in a drill. This I'm just using in a, I don't know, some kind of Dynabraid air motor like that. And then for the inside, I just use your standard 80 grit flap wheel for a die grinder like that. You just stick it in there, just run it until you can't really see any more, you can't really see any more weld, and you just get a nice, real even finish. So I'm gonna go ahead, I've got a fan over here. I'm gonna turn it on a low, just so, whoops, and it's pointed the wrong direction. Just to get that dust and stuff out of my face. Normally I'd wear a face shield and a respirator for this, but I want to be able to talk through it. However, I am going to put in some earplugs because this is loud and I don't really want to go deaf. So we'll go ahead. We'll start off with the gray wheel here on the outside. There we go. All right, well, I hope you guys enjoyed this video. Here's the final product. Turned out pretty decent, just until the next time they tear this up again. But like I said, these are a little over $1,000 new, and I saved them a pretty good chunk of money here. And I've been at this for an hour and a half, and I'm gonna make some pretty decent money off of it. So if you can get in with a plant that has stuff like this and you can actually fix things, do some sanitary welding like that, and just some polishing, hey, this is a really good money maker. And it saves the customer money, and I turned this around less than 1 day, and ordering a new one of these, it'll be middle of next month by the time the new ones of these are actually delivered. So faster turnaround time, save the customer some money, made good money on it. Everybody wins. I thank y'all for watching. Hope you enjoyed this video. You got another idea for some just quick sanitary projects like this that make great money, drop a comment below. Thank y'all for watching.